Hello and welcome. Thanks for making the time to watch this video. My name is Shia Nafti. I'm an authorized trainer for Google. I travel around the world delivering training to Google's clients and partners. In today's session, we're going to explore Istio, a service mesh that you can use on the Google Cloud Platform. In this demo, we're going to deploy a retail store application across two clusters, one in the US and one in Europe. We're going to start by downloading the service mesh. The version of the service mesh we're going to download is version 1.2.2. Next, we're going to enable a couple of APIs to services we're going to use during the course of this demo. In the next step, we're going to create a network for our compute engine resources. We're going to create the network as an auto mode network. The auto mode network automatically creates a subnet in every region around the world where Google has a cloud data center. Before moving on to the next step, let's visit the Google Cloud Web Console to explore the network we've just created. To do that, we're going to navigate to the networking section, select VPC Network and VPC Networks. You can see here the network we've created. The network is called Single Control Plane Net. You can also see the regions around the world where Google has a data center. In each of those regions, a subnet was created and an IP address range allocated to the subnet. This enables us to provision compute engine resources in data centers located in any of these regions. Let's return to our Cloud Shell console and proceed to the next step, where we're going to create a Kubernetes cluster. Let's start by creating the first cluster in Europe. The first cluster will be a 2-node cluster with auto-scaling enabled, allowing us to scale to up to 4 nodes. Let's switch context to the current cluster. And retrieve its credentials. Let's use the credentials to grant admin privileges to the current logged-in user. Let's create a cluster in the US. Let's enable auto-scaling and specify the number of nodes as 2, with the possibility of scaling to up to 4 nodes. Let's change context to this cluster. Let's retrieve the cluster's credentials. Let's use the credentials to grant admin privileges to the current logged-in user. Let's explore the Kubernetes configuration in the Google Web Console. To do this, we're going to navigate to the Compute section, Kubernetes Engine, and select Clusters. You can see here the two clusters that were created, Hipster SCP-1 in Europe and Hipster SCP-2 in the US. Both clusters have 2 nodes. This equates to 8 virtual CPUs and 30 gigabytes of memory. Let's explore the configuration for one of the clusters. The version for the master is specified along with the API endpoint. We can also see here confirmation on the zones for the master and nodes as well as the network. Here we can see the IP range, the range of IP addresses that have been reserved for pods that will be provisioned within this cluster, as well as the range of IP addresses reserved for services. At the bottom of the page, you can see here the default pool configuration. The nodes within the cluster will have this Kubernetes version. There are currently 2 nodes. Each node is of this machine type. The image type for the cluster is the container optimized OS image. Autoscaling is enabled. Let's return to our Cloud Shell console and proceed to the next step. In the next step, we're going to configure a firewall rule. The firewall rule will allow traffic to flow between services that are running on the Compute Engine instances within the cluster. Let's select option 5 to proceed. We've set a priority of 900 in order to make this firewall rule more important than the firewall rules that are automatically created when Kubernetes clusters are provisioned. The source ranges for the firewall rule are the IP address ranges that will be allocated to pods configured within the cluster. The target tags are the tags associated with the cluster virtual machines. Let's apply this firewall rule. Before we move on to the next step, let's go back to our Google Cloud Console and explore the firewall rule. To do that, we'll navigate to the networking section, select VPC network and firewall rules. Most of these firewall rules were automatically configured when the Kubernetes cluster was created. All of the firewall rules that were automatically created when the Kubernetes cluster was configured begin with GKE. The firewall rule was just created is the single control plane net firewall rule. This is an ingress firewall rule. We specify target tags. We also specified source IP address ranges. Let's have a look at the firewall rule configuration in detail. These are the tags that are assigned to the firewall rule, as well as the IP address ranges and the protocols. You can see the Compute Engine virtual machines here, as well as the tags. Let's return to our Cloud Shell console and proceed to the next step, which is step number 6. In step number 6, we're going to install our service mesh into these 2 clusters. Let's start off by changing context to the cluster in Europe. Let's retrieve the credentials for the European cluster. Having retrieved the credentials, let's create a namespace for the Istio system components. Next, we're going to change into the directory where Istio was downloaded and extracted. We're going to copy the configuration file for custom resource definitions into a YAML file, which we're going to apply onto the cluster. Next, we're going to use Helm in order to add additional configuration into this YAML file for configuring the additional Istio service components. Let's label the namespace where our application will be deployed. That's the default namespace. We're labeling this namespace for automatic Istio sidecar injection. Let's apply the custom YAML file to our Kubernetes cluster in order to install the Istio system. In order to allow access to the Istio control plane service components from a remote cluster, we're going to change the service type of the control plane services to a load balancer service type. Let's change the service type for the Istio policy component. We're also going to change the service type of the Istio telemetry component to a load balancer service type. Let's set the pilot service IP as an environment variable. Let's also set the policy service IP as an environment variable. And finally, the telemetry service IP also as an environment variable. Using these environment variables, we're going to create the YAML file which will be applied to the remote cluster to enable the remote cluster to have access to the control plane running in the primary cluster. In this demo, the primary cluster is the cluster in Europe and the remote cluster is the cluster in the US. We're now going to use the Helm template command to generate a custom YAML file for installing Istio on the remote cluster. Here you can see that we're setting the remote pilot address, the remote policy address, and the remote telemetry address using the values from the environment variables we recently created. We're going to apply the istio.remote YAML file once we've switched context to the cluster in the US. Let's proceed and switch context to the cluster in the US. Let's retrieve the credentials for the US cluster. Let's create a namespace for the Istio components within the US cluster. Let's label the default namespace for automatic sidecar injection. The default namespace is the namespace where we're going to deploy our application. Let's apply the YAML file we created previously onto the remote cluster. This customized YAML file enables the cluster in the US to access the Istio control plane components which are running within the cluster in Europe. Let's explore the Istio configuration on the Google Cloud Console. Let's navigate to the Compute section, select Kubernetes, Clusters. You can see the two clusters, the one in Europe and the one in the US. Let's have a look at the workloads running within those clusters. Let's sort by cluster. You can see here that the cluster in Europe, which is cluster 1, has a lot more components deployed within it. In cluster 1, we have the Citadel, Pilot, Policy, and Telemetry components, while in cluster 2, we have just a subset, Citadel, and a component for sidecar injection, as well as for secret cleanup. This confirms that the cluster in the US will make use of the control plane components that are running within the cluster in Europe. Let's take a look at services and ingress. You may also have noticed that the pilot, policy, and telemetry components, which need to be accessible from the remote cluster, that's a cluster in the US, have been configured with the load balancer service type. The pilot, policy, and telemetry control plane components are therefore accessible from the cluster in the US using the allocated public IP addresses. Let's return to our Cloud Shell console and proceed to step number 7. Let's switch context to the US cluster. Let's retrieve the credentials for the US cluster. Having retrieved the credentials for the US cluster, let's set the root certificate authority certificate as an environment variable. Let's also set the token. Let's set the key to the environment variable token. In this step, we're creating a configuration file which the Istio control plane running within the cluster in Europe will use to access the cluster in the US. This is important because the control plane requires access to all of the clusters within the mesh in order to discover services, endpoints, and pod attributes. We are now going to proceed and create this configuration file. This is the configuration file created. You can see here the certificate authority data and the credentials or the token for the cluster in the US. Let's return to Cloud Shell and proceed. Let's switch context to the cluster in Europe. Let's retrieve the credentials for the cluster. Let's create a generic secret in the cluster in Europe using the configuration file for the cluster in the US in order for the control plane to have access to the remote cluster. Let's label the secret. That completes the configuration that connects the control plane cluster to the remote cluster. Let's move on to step number 8, where we're going to deploy our application onto the cluster. Let's switch context to the cluster in Europe. Let's retrieve the credentials of the cluster. Let's apply the YAML files for the microservices to be deployed in the European cluster. We're now going to switch context to the cluster in the US. Let's retrieve the credentials for the US cluster. Let's apply the YAML files for the microservices to be deployed into the US cluster. Having deployed the application, let's explore the YAML files we applied using the Cloud Shell editor. From within the control plane working directory, there are two folders, cluster 1 and cluster 2. The deployment YAML file is the YAML file that was applied to configure deployments within cluster 1 being the cluster in Europe. We also applied the Istio manifest YAML file. This YAML file has gateway, virtual service, and service entry configurations. We also applied the services-all YAML file, and this services-all YAML file has the configuration for the services. In the US cluster, we applied just two configuration files. the configuration file for the deployment, as well as the configuration file for the services. Let's navigate to the Google Cloud Console and explore the application configuration. Let's select the Workload tab. You can see all of the workloads. Everything appears to be running just fine. Let's sort based on cluster, and let's filter. Let's select the default namespace. You can see here the workloads that have been configured for the two clusters. In cluster 1, we have a majority of the microservices deployed. And in cluster 2, we have two microservices, the card service and the recommendation service. We also have a load generator microservice that generates load behind the scenes. Let's navigate to the Services tab. Let's sort by cluster. And let's filter. Namespace, default. You can see here the services for the cluster in Europe, as well as the services for the cluster in the US. You may have noticed that we have the full set of services configured across both clusters. However, you can tell where the pods are running. So in this instance, we have a service configured for the card service. However, there's no pod running within the cluster in Europe. The recommendation service is running in the US cluster. The recommendation and the card service are the only two services running in the US cluster. Let's remove our filter in order to view the ingress gateway configuration. This is the ingress, the IP address that allows us to access the resources running within the cluster. Let's click on this in order to access our application. And here you've got our application running. Let's purchase a few items. We'll add a vintage camera. Let's also purchase this bike. And let's place our order. This confirms that the hipster shop was successfully configured. Thanks for watching and hope you enjoyed the video. Have a nice day.